Okay, this is kind of the next logical part of the process. So we've done things like we've shot on straight ground, we've shot on cliffs, and when we did this we'd say, well, delta y is equal to 0, delta y is equal to height. Now we're going to do something which is a little bit more interesting. We're going to shoot up a hill and we're going to say, well, how are we going to do this? This looks a little more complicated. Now walking around, not a lot of people did what I would have done immediately, which is, what do I know, what do I not know? Because when you have a better grasp on what you actually have in your pocket, it gives you a better idea of where to go next. Now you look at this and you say, well, this is going to be a nice constant velocity problem, so I'm entitled to use the magic 5. And for the magic 5, I'd write down, well, x and y and v initial, v final, acceleration, delta t, and displacement. And this kind of might be disheartening because you'd say, well, what do I really know? Well, I know my v initial in the x direction is going to be v cosine theta. And I guess I've just made that direction positive. And I know that v in my y direction is going to be v sine theta. So I guess I've made that direction positive. I don't know what v final is. For acceleration, I know that's 0. I know that that's minus g. I don't know what my change in time is. And I don't know what my displacement is. And then you immediately say, I kind of feel like I'm in trouble here because Magic 5 always tells me that I have information about 3 parts and I can use that information about 3 parts to solve for a 4th part. And I only have 2 parts. I don't have 3 parts. Somehow I have to figure out one more variable. But it turns out that there's one more thing that you know. You say, really? There's one more thing I know? I say, there's totally one more thing that you know. You go over that far, that's delta x, and you go up that high, that's delta y, and I still have that angle in there. Okay? Now some people are going, oh man, I should have thought about the trig. Because what this is doing is that this is giving you a relationship. Delta y divided by delta x is equal to what? Tangent phi, opposite over adjacent. Okay, well, phi is given, so I know what tangent phi is, and now I just need to know what delta y divided by delta x is. Well, delta y, that's just going to be v initial in the y direction, which is going to be v sine theta times t minus 1/2 g t squared. Well, delta x, that's going to equal v cosine theta t. So if I want to know what tangent phi is, I would just divide delta y divided by delta x. And that first term, I'm going to have a v sine theta t divided by v cosine theta t. The second term is going to be a g t squared divided by 2v cosine theta t. I can simplify this. Tangent of phi is going to equal, well, those v's cross out and those t's cross out. Sine theta over cosine theta minus, well, those t's cancel out, gt over 2v cosine theta. I can rewrite this. I can say gt over 2v cosine theta is equal to tangent theta minus tangent phi. And then I can just solve for t. And that would be 2v cosine theta over g divided by, or excuse me, multiplying tangent theta minus tangent phi. If we're being very careful, what do we do at this stage?
Check the units.
Check the units. Thank you. So t should be measured in seconds. these tangents are going to give us stuff that's unitless, dimensionless, so they just drop out. The velocity is in meters per second. Cosine, again, is unitless. Gravity is going to be meters per second squared. Meters per second cancel out with meters per second. So I'm dividing by 1 over seconds. So my answer actually is in seconds, as I would expect. So now I've figured out what t is. I would just go back right here, plug that in, and figure out what delta x is. Okay? That's one way of solving this. There's another way of solving this. You say, well, what's the other way of solving this? The other way of solving this is to just kind of take your head and flip it sideways. If you take your head and flip it sideways, you'd say, well, here is the ground. And that's phi over there. Here's the slope. And I'm going to shoot a cannonball, and it's going to kind of go like that. And you say, I feel much more comfortable solving a problem like that because in that case, delta y is equal to 0. Okay? What's the complication if you do this? Gravity. Okay? Usually when we're shooting stuff, when we're worried about delta y is pointing straight down. But what we've done here is that we've rotated our coordinate system. So now gravity is no longer pointing straight down. Gravity is pointing, well, in that direction like that, at right angles to the ground. So that's what gravity is doing. This angle in here is going to be theta minus phi. Okay? So you could go through, make this a magic 5 problem. You just have to be a little bit careful. So let's see if what we get when we do this. So here's x, here's y. So we have v initial, v final, acceleration, displacement, and delta t. Okay? The reason we flopped it over like this is because the displacement becomes easy. Now our displacement in the y direction, I'm going to call this y positive and x positive. Maybe call these x prime and y prime because they aren't really our traditional x and y. Our displacement in the y prime direction is equal to 0. Okay? That's what's really being advantageous for us here. And we can turn around, we can say, well, we can figure out our initial velocity. We're going to have v cosine theta minus phi. We're going to have y prime is going to be v sine theta minus phi. We don't know about v final. And here our accelerations get a little interesting. Okay? So what's our acceleration for gravity? Okay, what's our acceleration in the y prime direction?
G sine phi.
So we hear g sine phi. And my question would be is, if phi went to 0, would we believe that? Yeah, I'm thinking this is a cosine here. Okay? So I'm thinking it's g cosine phi. Because if phi went to 0, we would expect g to basically restore itself to g. We need to be a little careful here. We also need a minus sign because it's pulling us down that axis. Here we also have a minus g sine phi. Okay? So from this right here, we could do what we've done before. We could say we have an initial velocity in the y direction. We have got a acceleration. Delta y prime is equal to 0 is equal to v sine theta minus phi times t minus 1/2 g cosine phi t squared. Then we can solve for t. Okay? Then we turn around and we'd have to say, well, what's delta x prime? Well, unlike most of the projectile motion problems we now have an acceleration along this direction because we've done something weird and we've kind of put gravity in an interesting situation. Here we'd have v cosine theta minus phi t minus 1/2 g sine phi t squared. That would get us delta x prime. Okay? Now here's an important question. Are we done?
No,
Why aren't we done?
because we need actually the horizontal displacement.
Exactly. What we've done here is that we've discovered our we've discovered our displacement along the hypotenuse here. Okay? So what we've solved is this distance here. So you'd have to do a little bit more trigonometry to get that distance there.